Good day, class. For this week in General Mathematics, Quarter 1, Module 6. The title of our module is Solving Exponential Equations and Inequalities. And then we will also be talking about how to graph exponential functions. And for day 2 class, for our Quarter 1, Module 6, we will have this lesson 14, and that is solving exponential equations and inequalities. Now, what would be our lesson objectives for this day? First is to recall the laws of exponents. Second is to determine the property of equality for exponential equation. Third is to determine the property of exponential inequalities. And lastly is to solve exponential equations and inequalities, which is actually our lesson for this day. Okay? So, first, let us try to solve exponential equations. Let me have this for you. So for lesson 14 class, there are two subtopics. That is to solve exponential equations. Then after that is to solve exponential inequalities. To further understand more on how to solve exponential equations, let's take it one by one. Okay? So let's do the recall first on how to identify exponential equations. Let's say, for example, I will give this to you. Now the question is, which of the following are exponential equations? Remember that you have an idea already, last week's lesson about exponential equations, identifying or determining those exponential equations. So let's try this. There are 4 examples of the expressions, and let's try to identify each of the expression if it is really an exponential equations. So try to look at the first expression. We have 8x is equal to x squared minus 9. Do you think this is an exponential equation? Look at the base 8x, where the variable x is served as the base. And so with the other side of the equation, and it is being raised to 2. So since the variable x is not being served as exponent, this one is not an exponential equation. Okay? So let's mark it as x. But there is equality. Second, we have 3 raised to the power of x is equal to 3 raised to the power of 2x minus 1. What do you think? Is this an exponential equation? You look at the variable x. It serves as the exponents of the base of 3. So with the other side. So this expression is an exponential equation. So let us try to box the answer. How about the third one? 5 raised to the power of x minus 1 is equal to 125. There is still equality. So, do you think this expression is an exponential equation? You look at the variable x, and that serves also as the exponent. So therefore, and there is equality symbol, therefore this one is an exponential equation. So let's back the correct answer. Okay. Lastly, we have 2 raised to the power of x minus 2 is greater than 8. So try to see this one, class. the variable x is serve as an exponent, but then the symbol in between the expression, in between the equation, is an inequality symbol. So this one is not an exponential equation. So let's mark it this as x. So out of the 4, there are only 2 exponential equations. We have 3 raised to the power of x is equals to 3 raised to the power of 2x minus 1, and 5 raised to the power of x minus 1 is equal to 125. I hope you're able to get what is really an exponential equation. Okay. To further understand about exponential equation and on how to solve, let us try to recall the laws of exponent. Okay, so let's have this laws of exponents. Let me put it all first. Recalling the laws of exponents, let's have this. A raised to the power of m multiplied to a raised to the power of n. That is equal to a raised to the power of m plus n. That means with the same real number such as your base, you just simply add the exponents on top of it. But if a raised to the power of m by n is equals to, you just simply multiply the exponents. So a raised to the power of m times the n. And then third, laws of exponent, we also have a and b, where a and b are real numbers and the two are being raised by an exponent of n. So what are you going to do with that? In the laws of exponents, simply each of the real number serve as coefficient. You raise it to its power. So that is equal to a raised to the power of n times b raised to the power of n. Another laws of exponents that you need to recall and remember is this one. A raised to the power of m divided by a raised to the power of n. So whatever real number is this, you just simply, when it is division, you just simply subtract the two exponents. So that means a raised to the power of m minus your n, where your a must not be equal to 0. Then we also have this one, a divided by b all over raised to the power of n. So what are we going to do with this? Since the fraction or this expression is being raised to n, you just simply multiply by its power. So a is equals to a raised to the power of n all over b will also be raised to the power of n. And make it sure that your b is not equal to 0 so that it will not be undefined. Also with the a, the fourth laws of exponents. Then what about if this laws of exponents here? A raised to the power of 0 is automatically equals to 1. That means any real number raised to the power of 0 is equal to 1. Then another one, we have a raised to the power of negative x. What if you have a negative exponents of that base? So simply give the reversed way so that it will give you a positive exponents. So actually this a raised to the power of x, it will become, this is all over 1 in fraction. So this will become 1 all over a raised to the positive exponent of x. Okay? So you just simply give the reverse way so that the exponent, negative x, will become positive. And lastly, we also have like this. So a raised to the power of a fractional part of exponents, which is x all over y. So what are we going to do with this? This will give you a rational. Is equal to whatever is your y. That means that gives you a square root, cube root, or whatsoever. So that would be the square root or cube root of what? Of your a raised to the power of your x. So this gives you a radical. Okay? So this laws of exponents will give you an idea or will help you out in solving exponential equations. And so with exponential inequalities. Now, let's try to practice or have an example, no? In giving a positive exponents to the given expression. Let me get this one first. Knowing the laws of exponent, let's try this. Simplify and express to positive exponents. So we have here 6 examples. So the first example is x cubed multiplied by x raised to the power of 5. So if you have here x cubed times x raised to the power of 5. To give the positive exponents, applying the laws of exponents, simply you will be adding the 2 exponents of the same base. So this will become x 3 plus 5 is equals to 8. So you've got x raised to the power of 8. And that's the answer. Second, you have here 2x raised to the power of 2 multiplied to the quantity of negative 4x to the power of 6. Okay. So, the coefficient, you multiply first. 2 times negative 4. That would give you negative 8. And then the variable base, which is x squared. And then multiplied by x to the power of 6. So, you have x. And simply add the 2 and 6 raised to the power of 8. So you've got the answer, negative 8 x raised to the power of 8. Third, let's try the third one. So you've got here 5 x squared times the 5x squared is being raised to the power of 3. So what are we going to do with that? In the laws of exponent, simply multiply by its power in each of the coefficient. So the 5 here will also be raised by to the power of 3. And this one also will also be raised to the power of 3. Okay? So 5 raised to the power of 3 is just simply 125. And this one is being multiplied by its power. So you've got x, 2 times 3, so you have 6. So the answer is 125 x raised to the power of 6. Okay, fourth. The fourth one, we have 12 x raised to the power of 10 all over 6 x raised to the power of 4. Remember, this is in division. The division in the laws of exponents. So, in division of the laws of exponents, simply subtract the 2 exponents of each coefficient. So, you've got here 12 divided by 6. That is actually 2. And this one here, you have the same variable base, x. So subtract this one. 10 minus 4. So you've got here 2x, and 10 minus 4 is 6. So this will be raised to the power of 6. So the answer we have 2x raised to the power of 6. Okay? So I hope you're able to get it. Let's have another example, which is the third one. The fifth. So if you're able to copy also or get the idea. So let me erase this part here so we can solve the rest of the two. So the fifth example, let's have negative 10 x raised to the power of negative 3 all over 15 x squared. So again, if this one is not, if you can find a common number divisible by the two numbers, then it will not give you a whole number right away. Okay? So simply think of a common number. So common number which we can divide both sides is what? We can divide that by 5. Okay? So dividing this by 5 and also here. So you've got here negative 2 all over. This will also be divided by 5. So 15 divided by 5, that would give you 3. That is by its common. Okay? So what will happen to the other variable x base? So that one x is equal to this one will become what? Negative 3 minus 2. Okay? Or simply you can do the other way also. Okay? So negative 3 minus 2. So what will happen to this? So we've got negative 2/3 x, and negative 3 minus 2 is actually negative 5. Now, our objective is to give the positive exponents. Simply, in the laws of exponents, we need to give the reverse way of this, no? So you have here negative 2/3, and this will become 1 all over x raised to the positive 5 this time. So we give the reverse of this as the laws of exponents. So you've got here multiply. So you've got negative 2 all over 3x raised to the power of 5. So this will become the positive exponents of the given example. Okay? And then we have the last example, which is quite complicated. The quite complicated is this one. So I hope you're able to get this one here. So let's try the last example. So for the last example, we have here negative 5x cubed all over raised to the power of 2 all over 2x squared raised to the power of negative 2, and everything is being raised to the negative 1. So if you have an example, or if you will be given an expression which is quite complicated, so simply you have to solve first the internal of the expression, then lastly would be the external one. So first is this one here. So we can simply solve the one inside first. So we can just write it here so that we can maximize the space. So for this, we will have here negative 5 still. So you have here 25 x raised to the power of 6. And then when you divide, you give the reciprocal of that, multiply it by reciprocal of 1 all over 4. 4x raised to the power of 4 is just 4x to the power of 4. Okay? Then everything will be raised to the negative 1. So you've got here 25 times 4. So that is 100. And this one, simply add the exponents, no? So you have x 6 plus 4, so you've got 10. And this one will be raised to negative 1. To give the exponent positive 1, give the reciprocal of that. So that is 1 all over 100 x raised to the power of 10. Okay? So this will be the final answer. So it's quite long because you need to simplify one at a time. Okay? So this will be for the laws of exponents.